Hi everyone, my name is Wendy, and today I'll be talking about carboxylic acid and ester nomenclature. In the description below, you'll be able to find a carboxylic acids and esters fact sheet and a general nomenclature rules reference sheet. The fact sheet serves to provide additional information about carboxylic acids and esters that's not explained in the video, such as solubility, boiling point, and real-life applications. The reference sheet is available for you to print out and utilize when working through the problems. Here's a summary for the naming rules of carboxylic acids. It's similar to how you would name aldehydes, as explained in my previous video. You would first find the longest chain connected to the double bonded and single bonded oxygen. It's not necessary to give location number for acids as it's terminal, so it's always first. After that, you would name the substituents hanging off of the main chain, and when putting it all together, you would remove the E from the parent alkane and replace it with anoic acid. For the first example, I'll be drawing cyclopentane carboxylic acid. Pentane indicates that there will be 5 carbons in the parent chain, and cyclo indicates that the 5 carbons will be in a ring. The carboxylic acid indicates that there will be an acid group, double and single bonded oxygen branching off of the ring. It will be given priority regardless of where it is on the parent chain, and the acid will be added to the name of the cyclic compound and given number 1 location number. Finally, we can check our work by numbering the chain and everything matches up with the name. Now I'll be drawing butane dioic acid. First, we need to determine how many carbons there are in butane, and that can be done by using the simple monkeys eat purple bananas mnemonic device, which is provided in my reference sheet. From this, we know that there's 4 carbons in the parent chain. The dioic indicates that there will be 2 acids connected to the parent chain. Since acids are terminal, we know that the acids will be found on the first and last carbon in the chain. We would then draw a carbonyl and hydroxyl group connected to both the first and the fourth carbon. Finally, we can check our work by numbering the chain and everything matches the name. Third example is 2,2-dimethylpentanoic acid. Pentane indicates that there will be 5 carbons in the parent chain. There's no location number indicating where the carbonyl and hydroxyl group in the acids are found because acids are always terminal and can be drawn on either side. Once the main chain is drawn, we need to draw the substituents. There's 2,2-dimethyl, indicating that there's 2 methyl groups connected to the second carbon. Finally, we can check our work by numbering the chain and everything matches the name. Now, for the fourth example, we're switching it up and we'll be naming the compound. First thing to do is to number the carbons in the main chain. We would begin with the carbonyl and hydroxyl group and then move towards the left. Using the monkeys eat purple bananas mnemonic, we get that there's 4 carbons in the parent chain, so it will be butanoic acid. Finally, we have to name the substituents. There's 2 hydroxy or OH groups on the second and third carbons. Remember that when there's 2 of the same substituents, there should be a prefix of di used. Pause the video and try to name it yourself before I reveal the answer. Combining it all together, we get the name 2,3-dihydroxybutanoic acid. Moving on to example 5, we'll be following along with the same process, counting from right to left, starting with the carbonyl and the hydroxyl group. There's 5 carbons in the parent chain, and that indicates that it'll be pentanoic acid. Next, we have to name the substituents. There's a methyl group hanging off of the second carbon. Pause the video and try to name it yourself before I reveal the answer. Combining it all together, we get the name 2-methylpentanoic acid. Finally, onto our last example. Counting from left to right, starting with the carbonyl and hydroxyl group, there's 6 carbons, which means that it'll be hexanoic acid. Next, we need to identify any substituents. On the 5th carbon, there's a ketone. As I explained in my previous video, when ketones are a substituent, it'd be named as oxo. Pause the video and try to name it yourself before I reveal the answer. Combining it all together, we get the name 5-oxohexanoic acid. Here's a summary for the naming rules of esters. Naming esters is a little different than what we've encountered in the past, but don't be discouraged. I'll teach you a few tricks and you'll be able to pick it up in no time. First, you would identify the oxygen of the continuous chain with 2 carbons on either side. On one side of the oxygen, there will be a carbonyl group, and on the other side, it's just a carbon. You would number the chains, starting from the ones right beside the oxygen. Once that's done, identify the side that's further away from the carbonyl group. That would be the alkyl group, the first part of the name. Once that's done, you'll add a space and then name the parent alkane, which is on the side with the carbon double bonded to the oxygen. The substituents would be named accordingly to whether it's on the alkyl chain or parent chain. Once that's done, you'll combine it all together and you would change the ending of the parent chain from E to O8. For the first example, I'll be starting off easy by drawing methyl ethanoate. A simple trick I use to remember is that the alkyl group is far from the carbonyl, and the parent group is close to the carbonyl group. We would then use this information to draw our diagram. We can check our work by numbering the chain and everything matches up with the name. I circled and drew arrows for clarity regarding the close and far groups. For the second example, I'll be drawing chloromethylpropanoate. Chloromethyl will be far from the carbonyl group, and propanoate will be close. Next, using monkeys eat purple bananas mnemonic, we get that propanoate is a chain of 3 carbon. Since there's a chloro before methyl, it's an indicator that there's a chlorine substitute hanging off of the methyl. We can check our work by numbering the chain and everything matches the name. I circled and drew arrows for clarity regarding the close and far groups. The third example is octyl ethanoate. Octyl is far from the carbonyl group with 8 carbons in its chain. Ethanoate is close to the carbonyl group. Then, using monkeys eat purple bananas, we get that the ethanoate chain will have 2 carbons. We would then draw them out with the 2-carbon chain connected to the double bonded oxygen, and then the 8-carbon chain connected to the single bonded oxygen. We can check our work by numbering the chain and everything matches the name. I circled and drew arrows for clarity regarding the close and far groups. Now, for the fourth example, we're switching it up and we'll be naming the compounds. First thing to do is to number the carbons on either side of the single bonded carbon. It's important to begin the numbering on the carbon right next to the oxygen. After that, identify any substituents found on the parent chain on either side. On the parent chain, or the group closest to the carbonyl group, we see a bromo group on the 3rd carbon. And then on the alkyl chain, or the group further away from the carbonyl group, there's a methyl on the 3rd carbon. Using the mnemonic device, the main chain has 3 carbons, so it will be propanoate, and the alkyl group has 4 carbons, so it will be butyl. Pause the video and try to name it yourself before I reveal the answer. Combining it all together, we get the name 3-methyl-butyl 3-bromopropanoate. Moving on to example 5, we'll be following along with the same process. First thing to do is to number the carbons on either side of the single bonded oxygen. It's important to begin the numbering with the carbon next to the oxygen. After that, identify any substituents found on the parent chains on either side. There's no substituents on this side, so all we need to focus on is identifying the names for the parent and alkyl group. The alkyl group is the one far from the carbonyl group, and since there's 2 carbons, it'll be ethyl. The parent group is the one with the carbon double bonded to an oxygen. Since there's 3 carbons, it'll be propanoate. Simply put, the parent chain is close and the alkyl group is far. Pause the video and try to name it yourself before I reveal the answer. Combining it all together, we get the name ethyl propanoate. Finally, onto our last example. The benzyl ring is something we've never encountered, but the process is the same. The benzyl group is close to the carbonyl, so it's a parent chain. Then we would number the carbons in the other group far from the carbonyl, which would be the alkyl group. Since there's 2 carbons, it would be ethyl. Pause the video and try to name it yourself before I reveal the answer. Combining it all together, we get the name ethyl benzoate. So that's it for the carboxylic acids and esters guided practice. There's additional practice questions provided where you can practice naming or drawing. I would recommend that you pause the video and try working through it yourself and then checking your answers after. If you're confused, rewatch parts in the video or use the general nomenclature rules reference sheet found in the description below. That's it for today's video. Remember to keep on practicing your nomenclature, and we hope that this video helped. Stay tuned for future videos, and bye for now!